we need to learn 2 more vocabulary terms. So basically 2 more patterns or trends that occur on the periodic table. So the first one that we're going to talk about is electronegativity. We write EN for short. So the definition is a measure of how strongly an atom or an element attracts an electron. So what it's saying is that the higher the electronegativity, that means the atom wants to get with an electron. So you can think of it as like this element really wants to get into a relationship with electron. Like it really, really wants to be boyfriend and girlfriend with this electron. Okay, so let's recap what we learned last time. When you talk about nuclear charge, we need to talk about protons. And this is when we have elements in the same row. In chemistry, we say period. So the more protons you have, the more nuclear charge you have. So you can think of this as like the more protons you have, it's like a really amazing person. They're strong, kind, they're amazing, and therefore the nuclear charge is very strong. So nuclear charge means pull. So you're going to think of it as they're giving them a nice, really big hug, really tight, close together because they love each other very much. And remember, this is a love story between protons and electrons. So the attraction is really, really strong. And so therefore the hug, the nuclear charge is very, very tight. Okay. That means that the electronegativity is also very high because it really wants to be in that relationship. It really wants to get together and be loving and be happy. Okay, so now if you think about it the opposite way, you know the less protons you have, it's a very weak person. Weak inside and out. So they are not going to love on that electron very much. They don't really care to get an electron. They don't want to be in a relationship. So they're not really going to hug that electron. They're just going to be like, I don't really want to touch you. Okay, you're going to think about like having a cringy side hug. Okay, the attraction is going to be very low if you have low protons, and therefore it's low electronegativity. They don't want to be in a relationship with an electron. Okay, now the other side is when we have elements in a group. Okay, so this means in a column. So the most important thing are energy levels. So you have to remember that the more energy levels you have, the more electron distance you have. So you got to think about it like this over here. Okay, in a group, okay, you have more and more energy levels, and energy levels are those rings. So the more that you have, you can see that you get further and further apart. Okay, when you are close together, the love is very strong because you are physically close together. It's like you go to the same school. Okay, but here, if you look at the bottom, the love is going to be very, very weak because it's like a long distance relationship, right? This long distance relationship in chemistry, it's not really going to work out. They're probably going to break up. Okay, so going back here. So the more energy levels you have, the further apart that they are. So they are very far apart. That means that they are not going to stay together because the attraction is very low. They're so far apart. That's why the electronegativity is low, meaning that they have no interest in getting into a relationship with an electron. Okay? So if we were to sum this up on the periodic table, the trend looks like this. Electronegativity gets bigger to the right and up. Okay, but little side note here, if we know it's all about getting an electron, do noble gases actually want to get an electron? The answer is no. They're already happy the way they are. So just realize electronegativity does not apply to your noble gases. So it gets bigger in this corner, meaning that fluorine has the largest electronegativity. So let's apply this knowledge to an example problem here. Okay, so this asks about the smallest electronegativity between thallium, indium, gallium, and boron. So it's a really good idea to mark your elements. Okay, so let's mark, let's see, they're either going to be all in the same row or the same column. So here's boron, here is gallium, indium, and thallium, like this. Okay, so now we're going to answer the question, or actually we're going to draw the arrow. So you notice that these are all in the same column, right? And so they are, electronegativity gets bigger going up. So you draw an arrow going up. So if you want the smallest electronegativity, then you need to find the element on the bottom. So thallium has the, and you're going to copy that phrase right here, the smallest electronegativity of the given elements in this, and this is a column, but in chemistry we say group. Now when you decide what this word is, period or group, then you have to have matching words here and here, right? So they come in a set, okay? So you always have to have the three words that go together. So group always talks about energy levels and electron distance. So just like the picture I showed you earlier, like when you think about a group, you have to think about those rings and the distance between your protons and electrons. So you found the words, and now let's fill in the appropriate words that make sense here. So we are saying that thallium has the smallest electronegativity, meaning it has no desire to be in a relationship with another electron. It doesn't want an extra electron, okay? Very, very low desire. It doesn't care to be in a relationship. So the question is why? Why does it not care? Well, if you notice that thallium is on the bottom of the periodic table here. So if we look here, thallium looks like this picture here, okay? We notice a comparison to the others that thallium has the largest or the most amount of energy levels. So here we're going to write largest. It has the most amount of rings, right? If you have a lot of energy levels, then what do we notice about the distance between your protons and electrons? It's also very large, okay? A little pattern here is that these two words should always match. So here and here should always match. Okay, because if you have a lot of energy levels, you are going to have a huge distance between your protons and electrons. Now, the last word here is about attraction. So you got to think, okay, do they love each other or do they not? Okay. If they are very, very far apart from each other, then remember they're in a long distance relationship, okay? It's like your boyfriend or girlfriend are at a different school, okay? And you have no cell phone, no internet, you don't have much contact with them, most likely going to break up. So the love is really not there, okay? So for here, we say that it has the smallest attraction. Some people like to say it has a weak attraction. Okay, like they don't really like each other very much. Okay, now the next trend that we're going to talk about is called ionization energy. Ionization energy is a measure of how much energy it takes to remove an electron from an atom. So when we have high ionization energy, it means it's harder to remove an electron. In my analogy, it's like saying, how difficult is it to break up a relationship between the protons and electrons? So all elements are in a relationship. The question is, how easy or how hard is it to home wreck their relationship? Is it easy to break them up, okay, or not? So once again, we know that protons and nuclear charge go together, okay? So the more protons you have, the stronger the hug that you have. It's a pull. That means you love each other very much. If you love each other very much, you're in a very loving relationship, then it's difficult to remove that electron. You can't break them up. They love each other. They're in love. They're not going to leave for a different element. They're in a loving relationship, so they're going to stay, okay? Now, the other flip side, okay, over here, if we're talking about a group, you have to talk about energy levels. So here, if you have a lot of energy levels, the distance between them is very far apart. That means they don't really love each other very much. The attraction is very low. If the attraction is very low, then you think that it is pretty easy to break them up, right? So if another element were to come around over here, was like, hey, look at this electron. Hey, do you want to get with me? You want to hop on this train? Then that electron's like, yeah, sounds like a great idea, or sounds like a great idea. And then they're going to leave for a different element. Okay, it's easy to pop that electron off. Okay, they don't want to be in this relationship anymore. Okay, so the trend looks like this on the periodic table. Ionization energy increases to the right and increases going up. Okay, so it's very difficult to remove electrons in the corners. So over here, these elements over here, okay, have very high ionization energies, okay, because they're in loving relationship. If you're like, hey, do you want to leave your boyfriend and girlfriend for me? And they're going to be like, no, I'm in a loving relationship. Like, no, I'm in a loving relationship. I love this person so much. I will never break up with them. Okay, so they are very difficult to separate. Okay, so let's try an example problem together where we are doing ionization energy. Okay, so we need to find nickel, titanium, bromine, or potassium. Remember, all of these elements are either in the same row or the same column. So nickel is here, okay, and then there's titanium here, then bromine is here, and potassium is here. So what you notice is that these are all in the same row. Ionization energy increases going to the right, so you should draw your arrow like this. It wants the largest ionization energy, so that's here. This element is bromine. Bromine has the, and we're going to write largest ionization energy of the given elements in this row. In chemistry, we have to say period. Now think about what this statement means. This means that bromine is very difficult to break up. They're in a very loving relationship. That's why they have the largest ionization energy, okay? It's very difficult to home wreck this couple, okay? These protons and electrons love each other very much, okay? So we're going to explain that in the next following sentence. Remember that when you write the word period here, you have to write the corresponding words that go along with it, okay? So those words is that period is protons and nuclear charge. The reason why we do not talk about energy levels is because you notice that all of these elements are all on the fourth row, meaning all of them have 4 rings. They all have 4 rings, so they all have the same number of energy levels. So it makes no sense to talk about energy levels. So we have to talk about protons instead. Okay, so now we have to fill in the rest of the words that is talking about bromine. Okay, so we have to learn the differences between these elements in their number of protons. So let's mark it over here. Potassium has 19 protons, titanium has 22, nickel has 28, and bromine has 35. So bromine is our answer, so we look at this number right here. 35 is way bigger than 28, 22, and 19. So we say bromine has the largest number of protons. If you have a lot of protons, you're a very strong element, okay? Very strong. You're good looking. You're kind. You're amazing. You are beautiful inside and out, okay? And this beautiful person, this strong person, is going to give their protons and electrons the biggest hug of their life, okay? That means they have the largest nuclear charge. They are going to hug them very tightly, like give them the best squeeze hug of all time, because do they love each other a lot, or do they not love each other a lot? They love each other a lot. It's a very strong attraction. So you can write largest here, and you think of the word strong attraction. They love each other so much. That's why it's it's very difficult to break them up. That's why I have the largest ionization energy. So when you look at these trends, you have to just be careful about these direction of arrows. So when you see electronegativity, you know it gets bigger to the right and bigger up, okay? Ionization energy also gets bigger to the right and up. But atomic radius is the strange one, okay? This one, it gets bigger in what direction? It gets bigger to the left, going down. So every time you read questions about atomic radius, make sure you draw your arrows in the correct direction. Right? You should be able to do the practice. Good luck.